Before there were mouths, before there were mothers, or mornings, or the sweet ache of hunger, there was just the question: how does life keep going? It sounds simple. It isn't. Because staying alive has always had a price, and someone or something has always had to pay it. Go back, far back, 2 billion years. The earth is unrecognizable. No green hills, no bird song, no tide coming in at sunset. Just water, mineral, light. And in that water, silence. Expert, it isn't silent at all. In a single droplet, one you could hold on your fingertip and not even notice. There are thousands of lives, tiny, invisible, determined. Microbes drifting like dust through a cathedral of ocean. And for a very long time, survival looked like this: wait, float, and hope that something useful drifted close enough to absorb. It wasn't elegant. It wasn't fair. Some cells got lucky. Most didn't. Life in those early ages was essentially living off crumbs. But here is the thing about crumbs. They're enough, just barely, if you never ask for more. The moment a cell tries to grow, everything changes. More space means more repairs. More repairs means more energy. More energy means you need more crumbs, faster than they arrive. So life faced a quite ancient trap. Ambition is expensive, and the only currency is energy you don't have. For millions of years, life solved this problem the same way. It stayed small, not out of weakness, but because the math simply did not allow more. And then, in the way that the most important things often happen, something changed. Not with a bang, not with a storm, just quietly. A new kind of cell appeared in those waters. Nothing about it announced itself as extraordinary. No weapons, no armor, no special gift that you could point to and say, there. That's the one that changed everything, except for this. Its outer wall was flexible, not rigid like the others, not locked in place. It could bend, it could stack, it could, if the moment was right, reach. Imagine you are that cell. A smaller microbe drifts toward you. In the old world, it's just competition. Another survivor pulling from the same thin soup you are already losing. But something different happens now. Your membrane moves, slowly, almost gently, like a hand closing around something precious. It wraps, it seals. And the other cell is inside you, not absorbed, not dissolved, from a distance, brought in, held, consumed whole. This is not violence, exactly. It's more like the first act of intention in the history of life. For the first time, something living didn't just wait for the world to feed it. It chose to be fed. The difference seems small. It is not small. Absorbing loose nutrients is pocket change. Engulfing a whole living cell, that's a fortune. And with that fortune comes a question life had never been able to ask before. Not just, can I survive today? But, for the first time, with something almost like wonder. If I had more energy, what could I become? There is something in that question that should feel familiar because it still lives in you. Right now, as you sit here, your immune cells are patrolling quietly through your blood. And when one of them meets a bacterium, it doesn't fight the way you'd imagine. No clash, no struggle, it simply wraps, reaches out, surrounds, closes, pulls the invader into a sealed pocket, breaks it down in a controlled chemistry managed room. The same motion, the same logic. 2 billion years later. That's not a metaphor, that's memory, written not in words, but in the living machinery of your body. So, when we talk about the first predator on Earth, we are not talking about something cold and ancient that gone. We are talking about a skill your body still remembers. And that's why this moment matters, not just as science, but as something you can almost feel. Before eating existed, life waited. It floated. It hoped. It survived on whatever the world happened to offer. After eating, life began. For the first time, to reach out and take. One small wrap at a time. Life stopped being passive. It started having intentions. Now, let's slow it all the way down. Watch it happen, step by step, the way it actually did, in the dark and patient water. At the beginning of everything, the big cell doesn't guess. It drifts, but not aimlessly. It follows the faintest chemical whisper in the water. A trail so thin, so subtle, that we would have no word for it, except that scientists do. They call it Chemotaxis, but you can think of it simply as this. The cell knows somehow which direction is toward. That's all hunger really is. At this most basic, not desperation, not violence, just learning toward what you need. And then contact. The membrane, that soft and flexible outer skin, begins to change shape. Not suddenly, not aggressively. More like the way water moves around something it wants to hold. Small folds appear at the surface. Pseudopods, scientists call them, but forget the word. Think of them as arms, slow, patient, unhurried. They reach outward. They curve around the smaller cell. One side, then the other. And they close, like a door softly shut. Now the smaller cell is inside, sealed in a pocket, a private bubble, pinched off from the world outside. And here, in that tiny enclosed space, something almost alchemical begins. The big cell changes the chemistry of the room, makes it more acidic, sends in molecular tools, enzymes essentially that do one patient thing. They take apart. Proteins become amino acids. Membranes become fast. DNA becomes raw material. Nothing wasted. Nothing lost. In nature, that is no such thing as garbage. Only things waiting to become something else. And then the payoff arrives. Energy, materials, not in a slow, uncertain trickle, but in a rush. For the first time in the history of life, a cell didn't wait for the world to feed it. It fed itself. Now, you might think the story ends there. Predator eats prey. The strong survive. Repeat. But nature, as it turns out, is more imaginative than that. Because sometimes, not always, But sometimes the swallowed cell doesn't die. Maybe it produced something useful, a burst of extra energy, a helpful chemical, something the host cell finds worth keeping. And so the host pauses, holds back, stops digesting. What began as a meal becomes a guest. What began as hunger becomes slowly something that looks almost like trust. Now the ocean changes, quietly, but forever. Because once one cell learns to swallow another, every other cell inherits a question it cannot escape. Am I easy to eat? Until this moment, the ocean was essentially a shared table. Crowded, yes. Competitive, yes. But everyone was after the same thing. Dissolved chemicals, drifting light, scattered crumbs. Now the food isn't just the chemicals anymore. You are the food. And so, quietly, life begins to answer back. The smallest cell start clustering. Not out of affection, not out of any plan, but because alone. You are easy to surround. A single drifting cell is a gift to a predator. A cluster? That's harder. Like trying to grab a fistful of sand instead of a single grain. Others grow slippery coatings. Tougher walls, small, unglamorous, upgrades that make them just difficult enough to not be worth the effort. And many simply disappear from open water altogether. They find rocks, they cling, they build thin living carpets across the seafloor, microbial mats. Layered neighborhoods where outer cells take the first hits, and the ones buried underneath live another day. And while prey learners to hide, predators learn to hunt, better at reading chemical trails, faster at trapping, more precise about which direction is toward, not because they're cruel, because nature, with patient ruthlessness, rewards however wasteless. Biology calls this an arms race, but you can feel it as something simpler, something almost human. Pressure creates invention, and predation, more than almost anything before it, creates pressure. Here is why that matters. Invention is expensive. Every new defense costs energy. Every new movement costs energy. Every upgrade, every internal tool, every small improvement costs energy. So when eating spreads through the ocean, the economy of life changes fundamentally. Energy no longer arrives only as scattered crumbs. Now it arrives in packets, whole cells broken down, turned into fuel in one concentrated burst. And when energy stops being fragile, when there is finally enough, life can finally afford bigger experiments, bigger cells, internal compartments, more careful control of DNA, the first hints of real organization. The predator didn't just change who survives, it changed what's possible. But the strangest consequence of all isn't hunting. It's what happens when the hunt pauses. Sometimes the swallowed cell doesn't get digested right away. Maybe it produces a useful chemical. Maybe it handles something toxic the host cannot. Maybe it simply does one job, quietly, reliably, every single day, better than the host ever could alone. And suddenly the math changes. Digesting gives one meal. Keeping it alive gives a benefit forever. So what began as capture becomes slowly something else entirely. A cell inside a cell, not as food, not as prisoner, as partner. Now, evolution isn't proud, it isn't cruel, it isn't even particularly interested in winners. It's interested in one thing only: what works. So forget friendship, forget mercy. What happened next wasn't beautiful, at least not at first. It was simply useful. The host offers a wall around the guest. Safety, stability, a home that moves. The guest, in return, offers a service, extra energy, faster chemistry, a small but reliable advantage in a world where small advantages are the difference between today and tomorrow. No trust involved, no intention. Just two cells, each getting slightly more than they would have alone. It wouldn't have looked elegant. Most pairings would fail. Some hosts would finish the digestion. Some guests would escape. Many combinations would simply not work. But every once in a while, in some quiet corner of some ancient ocean, one pairing would hold. And the payoff was unlike anything life had experienced before. Not a burst of energy from one meal. Reliable energy. Every day, on demand. That word, reliable, changes everything. Because reliability is what lets you plan. And planning, even at the cellular levels, is how complexity begins. With reliable energy, a cell can afford a bigger genome, can afford internal organization, can afford new compartments, separate rooms where different chemistry can happen quietly, without chaos bleeding into everything else. Structure, control, specialization, the seeds of everything that follows. This idea has a name: Endosymbiosis, and it is the road that leads, through long and winding time, to mitochondria, to complex cells, to us. So, let's stay here for just a moment, before we move on, before the next mystery opens up, because it's worth pausing to feel the full weight of what just happened. A membrane learned to bend, a cell learned to reach, and with that one quiet move, softer than anything you could call dramatic, the ocean changed permanently. The first predator wasn't a monster. It wasn't even really a hunter. It was just a cell that learned to wrap its arms around the world, and in doing so, accidentally wrote the first line of the most improbable story ever told on this planet. Life building itself out of other life, not only by destroying it, but it keeping it, absorbing it, becoming, over time, inseparable from it. And here is what I want you to carry with you. We don't have footage of this. We don't have a witness. No record from 2 billion years ago. But we have something better. We have the evidence life never threw away. It's in your immune cells. It's in your mitochondria. It's in every complex cell on this planet. Each one a living archive of a partnership that began inside a meal. How does something you capture slowly become part of you? How does a meal turn into a relationship? How does that relationship change the future of life on Earth? That's where we are going. And I promise you, it's stranger and more beautiful than it sounds right now. Richard Feynman once said, and I think he was right. It's much more interesting to live not knowing than to have answers which might be wrong. That's the spirit of this series. Not to hand you conclusions, but to hand you better questions. If that's the kind of thinking you want more of, subscribe to the Discovery Muse. Because what comes next isn't just more information. It's a mystery that will change how you see everything we have talked about today. The meal that became a power plant, the capture that became a partnership, the moment that made complex life possible. It's waiting, right on the other side of one ancient question. What happens when you keep what you swallow? We will find out together.